Okay, I really like today's lesson because it explains something that you learned in Algebra 2 that we just kind of said, this is what this is, but it takes calculus to actually explain it. And that is, for some functions, the only way to define them is by using a definite integral. So a definite integral is an integral where you have the limits of integration on the top and the bottom. One such function is the natural log of x. Okay? We've been talking about the natural log of x since Algebra 2, but we've never really told you why those values are those values. And that's what we're going to talk about today. So the definition of the natural logarithmic function is the natural log of x equals the integral from 1 to x of 1 over t dt. All right, now first glance, and x has to be greater than 0. First glance, you may be going, what? But let's kind of break it down. If we take the integral of 1 over t between x equals 1, or between 1 and x, graphically or geometrically, what does that mean? Okay, exactly. The area under the curve of 1 over t from 1 to x. So let's graph 1 over t dt. We have to, okay, where's the t coming from? You have to use another variable. That I'll be able to explain where the t is coming from a little bit better in example 2. So just kind of hold that off. Hold off on that. But you have to use another variable than x, because if we were to evaluate this, then we would integrate 1 over t. So we get a function that's in terms of t, and then plug in the top number minus plug in the bottom number. So when you plug in that x, that's where the x comes from. Or you get back to the x. That's why you have to use a different variable than the x to start with. What does the graph of 1 over t or 1 over x look like? Okay, y'all are kind of doing it. We have asymptotes on both axes, and then the graph looks something like this. And technically, you have another part of the curve down here, except for this particular problem, x has to be greater than 0. So we're only going to talk about the part in the first quadrant, where x is greater than 0. So if I want to find the integral of 1 over t dt from 1 to x, then I'm finding the area between 1 over t dt from 1 to whatever x value I'm looking for. All right, so this is going to explain what the calculator does when you ask it to find, say, the natural log of 2. So using this definition of the natural log of x, the natural log of 2 equals the integral from 1 to what? 2 of 1 over t dt. Or if you don't like the t's, okay, going nuts. Ah! Stop. Yeah, I guess it doesn't like the t's. If you don't like using t's, then we can use any variable you want. So we could call this the integral from 1 to 2 of 1 over x dx. Yeah, once you replace the x with a number, then you can use whatever variable you want. You just need to be consistent. All right, so let's use our calculator to actually evaluate this integral. Well, there are two different ways that we can evaluate the integral. One is to use the home screen. You have to turn the calculator on, though, first. All right, so to use the home screen, where's the integrate feature? Under what button? F3. If we're using the home screen, then we go to F3. Number 2 is integrate. We want to integrate 1 divided by x, comma x, comma 1, comma 2. Now, My calculator is on this auto mode, and this auto mode means that if I use a decimal in the problem, it's going to give me a decimal answer, but otherwise it's going to give me the exact answer. So when I hit enter, I get the natural log of 2. But if I hit diamond enter, then you'll get the decimal approximation. So let's use the decimal approximation of 0.693. All right, the other way to find this integral is graphically. So go to y equals. And I kind of like this approach because it really reiterates that we're talking about the area under the curve. So the function is 1 divided by x. I'm trying to find the area between the curve, between 1 over x and the x-axis. For my window, I think I'm going to set, I don't want any negative x values, but I do like to be able to see that y-axis. So I think I'm going to go from negative 1 to 10 for my x's. And for my y's, I'll also go negative 1 to 10. So to find the integral on the graph screen, that's where we go to F5. And which number from there? 7. Lower limit is 1. Enter. Upper limit is 2. Enter. It shades that little area, and we should have expected it to be 0.693.
So how does that relate to finding the natural log?
Okay, so when the calculator finds the natural log of a number, what it does is it goes to the graph and it uses a Riemann sum to find that area under the curve, but it takes, basically an integral is the limit of a Riemann sum, and it's the limit as the number of rectangles approaches infinity, and the width of the rectangles approaches what? 0, right. So we're trying to find an infinite number of, we're basically adding up the areas of an infinite number of rectangles whose widths are approaching 0. So that's how the calculator actually finds the natural log of 2, is it takes that graph and then is programmed to find the area of all of those tiny, tiny, tiny rectangles. She is not here today. No. All right, so let's look at example 2. So what the calculator would be doing to calculate number 2 would be to find the integral from what to what? 1 to 4 of 1 over x dx. Okay, the question was, why is it from 1 to something? Right, you couldn't go from 0 because that's an asymptote. I'm sure the proof of that is in your book, but I can't answer that question right off the top of my head. All right, so to find this value, let's just go back to your graph screen. And under F5 and 7, lower limit 1, upper limit 4. And you get 1.386. Yes, and that's what I was just about to do. If you go back to your home screen and you plug in the natural log of 4, which natural log is the second of your x key, maybe, natural log of 4, and then you hit diamond enter to get the decimal approximation, it gives you exactly what we got. Well, I'd like for you to, I'm not going to ask you like on a test what the natural log of 4 is, but I'm just kind of using this to lead into the rest of the lesson. All right, the natural log of 1 would be the integral from 1 to 1 of 1 over x dx, which I've already heard someone say the answer, and that is 0. Right, because there's no width to the area of that. If you're going from 1 to 1, you have no width. All right, D, the natural log of 0.5, would be the integral from what to what? 1 to 0.5 of 1 over x dx. Okay, wouldn't that be a negative number? The answer to that is yes, because basically what you're doing is you're starting at 1 and then moving backwards or to the left. And that's why I taught you that property yesterday, I guess, that you can switch the limits of integration if you take the negative of that. So this is the same thing as negative integral from 0.5 to 1 of 1 over x dx. It doesn't like it, I don't think. Let's see what happens. Okay, let's go back to graph. Yeah, but I'm going to do the graph screen first. If you're doing a bunch of these problems and you're sick of seeing all this shading, under F4 that says regraph, and it'll regraph it and get rid of all the shading. So it's just kind of a little trick. All right, so F5, 7. I'm going to try to go make my lower limit 1 and my upper limit 0.5 because that's how I started out by the definition. I was integrating from 1 to 0.5. So lower limit 1, enter, 0.5, enter, and it gives me an error. Okay, so basically you have to know that you need to take, your lower limit needs to be 0.5 and your upper limit needs to be 1. Well, if you're doing it on the graph screen, you have the graph, and the lower limit is 0.5 and the upper limit is 1, and it gives you 0.693, but you're going to have to know to make that number negative. Okay. However, the easiest way is probably to just do it on the home screen. However, I just wanted to demonstrate graphically what's going on there. So on the home screen, it doesn't have a problem with, okay, so on the home screen, you can just do 1 divided by x, comma x, comma 1, comma 0.5. On the home screen, it knows. On the home screen, the calculator is programmed to flip those limits of integration and make it negative. But on the graph screen, because it specifically asks for a lower limit and an upper limit, the lower limit has to be smaller than the upper limit. Okay, and then last one on this section. So this still goes with part D. I'm sorry, this is all over the place. All right, part E is the natural log of -2. Good. That does not exist because up here by the definition of this, x has to be greater than 0. It'll just give you an error, I think. Try it. Oh, it's been busy. Question or undefined. The reason that natural log of -2 is undefined is because if you actually graph ln x, the natural log of x is only defined for x greater than 0.